Tonight, we are going to explore something that will fundamentally change how you see your place in the cosmos. We are going to discover just how small Earth really is. And I'm not talking about simple comparisons. I'm talking about the true scale. The scale that makes our world almost disappear. Because here is the thing most people don't realize. Earth isn't just small. It is so incredibly tiny that finding the right words to describe it becomes almost impossible. By the end of this journey, you're going to see our planet and yourself in a completely different light. From down here, Earth seems enormous. You could spend your entire life traveling and still not see every corner of it. The continents stretch for thousands of miles. The oceans cover 71% of the surface. Mount Everest rises nearly 30,000 feet into the sky. To early humans, Earth was everything. It was the entire universe. But this is an illusion. Let's zoom out, just a little bit. Our first stop is our nearest neighbor, the Moon. Most textbooks show the Earth and Moon close together. That is a lie. The Moon orbits Earth at an average distance of about 238,855 miles. It looks close? Think again. You could fit 30 Earths in the gap between us and the Moon. That is how much empty space exists in just our immediate backyard. And the Moon itself? If Earth were a basketball, the Moon would be a tennis ball. It's about 27% the size of Earth. Small, but significant. It stabilizes our wobble. It drives our tides. But as we leave the Earth-Moon system, we are about to leave the realm of human scale forever. Now, look at the Sunday. The Sun is the reason we exist, but it is also where Earth's dimensions truly begin to pale. The Sun's diameter is 109 times larger than Earth's. But diameter is misleading. We need to talk about volume. Imagine the Sun as a hollow sphere. You could pour Earths into it. 1, 10, 100, to keep going. You could fit approximately 1.3 million Earths inside the Sunday. Every mountain, every ocean, every city, every person who has ever lived, all of human history, happened on a planet whose volume represents less than 1/1,000,000th of the Sunday. The Sun contains 99.86% of all the mass in our solar system. Everything else, Jupiter, Saturn, all the asteroids, comets, and Earth, makes up only 0.14%. We are barely a rounding error in the formation of the Sunday. But the solar system is vast. Let's take a tour to see where we fit in this neighborhood. Mercury, a scorched rock, 38% the width of Earth. Venus, our toxic twin, 95% the size of Earth. It rotates backward, and its day is longer than its year. Mars, the red desert, half the size of Earth. It lost its atmosphere when its magnetic core died. Then, we reach the giants, Jupiter. This is not a planet, it is a failed star system. It is 11 times wider than Earth. Its volume could swallow 1,300 Earths. Look at the Great Red Spot. That is a storm that has been raging for 400 years. Now, it's shrinking, but it could still swallow our entire planet whole. Saturn, the jewel, with rings that extend tens of thousands of miles but are thinner than a piece of paper if scaled down. Saturn could hold 764 Earths. Its moon, Titan, is larger than the planet Mercury and has lakes of liquid methane. Uranus and Neptune, the ice giants, each could hold roughly 60 Earths inside them. Neptune is so far away it takes 165 Earth years to orbit the Sun once. Since we discovered it in 1846, It has completed less than 2 orbits. Let's pause here. At the edge of the solar system, if the Sun were a basketball, Earth would be a peppercorn 26 feet away. Neptune would be a football field away. And the Voyager 1 spacecraft, the fastest object humans ever built, it has been traveling for 47 years. It is currently 15 billion miles away, but in the cosmic scale, it hasn't even left our front porch. Now we leave the Sunday, we enter the interstellar medium. The distance between stars is so vast, our brains break trying to comprehend it. Our nearest neighbor is Proxima Centauri. It is 4.24 light-years away. That sounds small, 4. But a light-year is 5.88 trillion miles. Proxima Centauri is 25 trillion miles away. If you drove a car at highway speeds towards Proxima Centauri, it wouldn't take you a lifetime. It would take you 48 million years. Even Voyager 1, traveling at 38,000 miles per hour, would need 73,000 years to get there. And remember, Proxima Centauri is just down the street. It's a red dwarf, small, dim. Let's talk about the monsters. You think the Sun is big. The Sun is a yellow dwarf. It is average, mediocre. Let's compare it to Betelgeuse, the red supergiant in Orion. Betelgeuse is roughly 700 times wider than the Sunday. If you placed Betelgeuse where our Sun is, it wouldn't just swallow Mercury, Venus, and Earth. It would extend past the orbit of Mars. Earth would be deep inside its belly. But Betelgeuse is a child compared to UY Scuti. This hypergiant is 1,700 times wider than the Sunday. If UY Scuti replaced our Sun, its surface would extend past the orbit of Saturn. Imagine a sphere so large that you could fit 6.5 trillion Earths inside it. At this scale, Earth doesn't just look small, it ceases to exist visually. You cannot see it, you cannot measure it. To UY Scuti, our Sun is a grain of sand. And Earth is an atom on that grain of sand. And yet, all these stars we've just seen, every single star you can see with your naked eye in the night sky, they are just a tiny bubble around us. They all belong to one city, the Milky Way. The Milky Way is a spiral galaxy containing between 100 billion and 400 billion stars. It is 100,000 light-years across. Remember Proxima Centauri? That vast, impossible distance of 4 light-years? The Milky Way is 24,000 times wider than that. Where are we? We are not in the center. We are in the suburbs. The Orion Spur, about 26,000 light-years from downtown. It takes our Sun 225 million years to make just one trip around the galaxy. We call this a galactic year. The last time the Sun was in this position, dinosaurs were just beginning to conquer the Earth. Humanity has existed for less than 0.001% of a galactic year. At the center lies the beast, Sagittarius A*, a supermassive black hole with the mass of 4 million suns. Stars whip around it at 5% the speed of light. This is the anchor of our galaxy. And yet, even the Milky Way, with its 400 billion stars, its supermassive black hole, its spiral arms spanning 100,000 light-years, is just an island. Meet Andromeda, our big sister. It has 1 trillion stars. It is twice the size of the Milky Way, and it is coming for us. In 4.5 billion years, we will collide. But don't worry. Space is so empty that when these galaxies crash, it is unlikely that any 2 stars will actually hit each other. They will pass through each other like ghosts. Together, we form the local group, a neighborhood of about 50 galaxies spanning 10 million light-years. If the Milky Way was a coin, the local group would be the size of a large city block. You might think we are getting to the top of the scale. We are not even close. We have left Earth. We have dwarfed the Sunday. We have stepped outside our galaxy. But what lies beyond the local group creates a feeling of vertigo that the human mind is not designed to handle. We are about to enter the realm of superclusters, the great attractor, and the cosmic web, where Earth isn't just an atom. It is a quantum fluctuation in a sea of nothingness. We left our home in the local group, a small village of 50 galaxies. But the local group is just an insignificant appendage of something far larger, the Virgo Supercluster. This is a collection of galaxy groups spanning 110 million light-years. It contains at least 100 galaxy groups and clusters. Within it lies M87, a monster galaxy with a black hole 6.5 billion times the mass of our Sunday. If the Milky Way was a coin, the Virgo Supercluster would be the size of a large city. But in 2014, astronomers realized even the Virgo Supercluster is just a limb. It is part of a titan called Laniakea. In Hawaiian, it means immeasurable heaven. Laniakea is a supercluster of superclusters. It spans 520 million light-years and contains 100,000 galaxies. And here is the terrifying part. It is moving. All these galaxies, including us, are flowing like water down a drain. We are being pulled towards a mysterious point called the Great Attractor, a region of gravity so intense it is dragging thousands of galaxies across the universe. We can't see it directly because it's hidden behind the dust of our own Milky Way, but we can feel it pulling us. And beyond Laniakea, the Shapley Supercluster, even more massive, pulling Laniakea itself. At this scale, the Milky Way is just a speck of dust in a raging river of gravity. Zoom out again, to the largest scale possible. The universe stops looking like galaxies. It starts looking like a sponge. This is the cosmic web. Galaxies aren't scattered randomly. They cluster along thin filaments of light, stretching for hundreds of millions of light-years. These filaments are the highways of the universe. But between the filaments, there is nothing. These are the voids, vast, empty regions of darkness. The KBC void is 2 billion light-years across. If you were in the center of a void, you would see no stars, no galaxies, just absolute, suffocating darkness. These voids make up 80% of the universe's volume. The universe is not filled with stuff. It is mostly empty space, cold, dark, and indifferent. And Earth? In the context of the cosmic web, Earth doesn't just disappear. It enters the realm of the subatomic. If the cosmic web were an ocean, Earth wouldn't be a grain of sand. It would be an atom inside a grain of sand. We have reached the limit, the observable universe. This is a sphere with a diameter of 93 billion light-years. Why 93 billion? Because the universe is 13.8 billion years old, but space has been expanding faster than light. Inside this sphere, there are estimated to be 2 trillion galaxies, not stars, galaxies. The total number of stars? About 200 billion trillion. Imagine every grain of sand on every beach on Earth. That is still not enough to represent the stars in the universe. If you picked one random star in the universe, the chance of picking our sun is 1 inch 200 billion trillion, and the chance of picking Earth? It is effectively 0. But remember, this is just the observable universe. What lies beyond the edge? We don't know. It might be infinite. And if the universe is infinite, then math dictates a strange reality. Somewhere, infinitely far away, there is another version of you watching this video. In an infinite universe, everything that can happen will happen infinitely many times. Earth is not just small, it is redundant. We have talked about space. Now, let's talk about time. Because Earth is not just small in size, it is insignificant in time. The universe is 13.8 billion years old. Let's compress that into a single calendar year. The cosmic calendar. January 1st, the Big Bang. The Milky Way forms in March. Our Sun and Earth, they don't even appear until September. For billions of years, Earth was just a rock. Life begins, simple and small. Complex life explodes in November. The dinosaurs? They appear on December 13th and die on December 26th. And humans? We appear at 11:56 p.m. on December 31st. All of recorded human history, every war, every invention, every pyramid happened in the last 10 seconds of the cosmic year. Our lives are not a blink of an eye. They are a fraction of a heartbeat in the lifespan of the universe. Given this scale, 2 trillion galaxies, 200 billion trillion stars. A question haunts us. Where is everybody? This is the Fermi paradox. Statistically, the universe should be teeming with life. There should be millions of civilizations older and more advanced than us. But we see nothing. We hear nothing. Just silence. Why? Maybe intelligent life is incredibly rare. Maybe civilizations destroy themselves before they can leave their planet. Or maybe space is just too big. Maybe the distances are so vast that we are trapped in our own little bubbles, destined to be alone forever. If we are the only consciousness in the universe, then Earth is not just a rock. It is a miracle. In 1990, Voyager 1 turned its camera back from 3.7 billion miles away. It took a picture. See that dot? That's here. That's home. That's us. On that suspended dust mote. Every king and peasant, every hero and villain, every creator and destroyer of civilization lived out their lives. Think of the rivers of blood spilled by generals, so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. The universe is vast. It is cold. It is mostly empty. Earth is tiny. But right now, it is the only place we know where the universe has opened its eyes and looked at itself. We are the universe, attempting to understand itself. So the next time you look up at the night sky, remember how small you are. But also remember, you are the part of the universe that gets to wonder. If this journey made you feel small, or if it made you feel precious, hit that subscribe button. We have an entire universe left to explore. Good night.